Hello guys, today we'll discuss gamma integral. So the indefinite integral of this type, integration 0 to infinity x raised to minus 1 e raised to minus x and the dx is called gamma integral. This is also one of the Euler form of integral, and this is equal to gamma of n, which is also equal to n minus 1 factorial. Okay, so this standard integral is helpful to solve many different kinds of integral. Let's see the following example. The first example is integration 0 to infinity e raised to minus x into dx. Here just compare this integral with the Euler form of integral. So assume there is x raised to 0 sitting here and find the value of n and put that into in this expression. Okay, so x raised to 0 is equal to x raised to n minus 1. So the value of n is n1. So this is equal to gamma of 1, that is equal to 1 minus 1 factorial 0 factorial, that is equal to 1. So the value of this integral is 1. We can also do this integration in the standard way and compare the results with these results, both will be same. Okay, now let's see this example. Integration 0 to infinity x into e raised to minus x into dx. Here the value of n is n minus 1 is equal to 1, n is equal to 2. So its value is gamma of 2, that is equal to 2 minus 1 factorial is equal to 1 factorial is equal to 1. Now coming to this integral, integration 0 to infinity x squared into e raised to minus x into dx, and here the value of n is n minus 1 is equal to 2, n is equal to 3, so its value is gamma of 3, which is equal to 2 factorial 2. So the value of this integral is 2. Now coming to this form of integral, uh, integration 0 to infinity e raised to minus x into dx. Here we can use the technique of change of variable. Let's make ax is equal to y and dx is equal to dy by a and put it here. Integration 0 to infinity e raised to minus y into dy by a, and that is equal to 1 by a into integration 0 to infinity e raised to minus y into dy, and we know this integral of this is equal to 1, so the value of this integral is 1 by a. Now suppose this is here the integral of this type is another version of gamma integral, and its value also is equal to gamma of n, and that is equal to n minus 1 factorial. So we can also prove it. Let's break this symmetric interval into two two times of 0 to infinity x raised to 2n minus 1 e raised to minus x squared into dx. Okay, I assume that this portion is even function, so the complete function will be even. And here let's substitute again using the change of variable technique. Let's substitute x squared is equal to y, and 2x into dx is equal to dy, and dx is equal to dy by 2 times x, but x is equal to square root of y. This is equal to dy by 2 times root y. Substituting this into the integration 0 to infinity x. Okay, what is the value of x? X is equal to y raised to 1 by 2 whole raised to 2n minus 1 and e raised to minus y, and dx is equal to dy by 2 times root y, and we can simplify this as this two will be cancelled, and integration 0 to infinity, you see here y raised to n minus 1 by 2, and this root y in the denominator can be written as y raised to minus 1 by 2 e raised to minus y into dy, and this is equal to integration 0 to infinity y raised to n minus 1 e raised to minus y into dy. And what is this? This is again the gamma integral which of first type which I told earlier, and this is equal to gamma of n. Hence this form and this form both are equal. So we can use either one depending on the type of integral that we are trying to solve. Let's take the example of this type of integral. So the integral minus infinity to plus infinity e raised to minus x squared into dx. So here we use the second type of gamma integral form, and here just come by assume that there is x raised to 0 is sitting and find the value of n. 2n minus 1 is equal to 0, n is equal to 1 by 2. So this integral value must be equal to gamma of 1 by 2, gamma of 1 by 2, and which is equal to root pi. So the value of this integral is integration minus 2 infinity plus infinity into dx is equal to root pi. That's all. Thank you.